Hello, intelligent. Welcome back to your physics lesson. Today I gonna teach you spherical mirrors. In previous videos, I told you about plane mirrors and formation of image in plane mirrors. In this video, I gonna teach you spherical mirrors. Spherical mirrors divided in two parts, or we have two kinds of spherical mirrors: concave mirror, convex mirror. With this concave mirror, if the outer surface of the segment is silvered, a concave mirror is obtained. Look at this figure. This is a spherical mirror. The reflected surface is curved surface, or we can say the reflected surface is a spherical surface. If the outer surface is silvered and the inner surface is reflective surface, we can say for this mirror concave mirror. Let's come to convex mirror. If the inner surface of this segment is silvered, a convex mirror is obtained. Look at this figure. The inner surface is silvered. The outer surface is reflected surface. This mirror called convex mirror. Let me tell you basic quantities in spherical mirrors. In spherical mirrors, we have some basic quantities that these are: center of curvature, the center of a sphere that a spherical mirror made of is called center of curvature. This point is called center of curvature. Center of curvature represented by letter C and also represented by 2F. 2. Principal axis. This line, the line that joins center of curvature with focus with pole, that line is principal axis. 3. The radius of a spherical mirror. The radius of a sphere is called radius of a spherical mirror. This distance, the distance between pole and its center of curvature, is called radius of a spherical mirror. This distance. And 4, focal point, or we can say focus. This point. Focus is a point that converges the incident ray. When incident ray comes and strikes the surface of the mirror, then reflects from the surface of the mirror. After reflect, pass through the focus. This focus is a point that converges incident ray after reflecting. And 5, focal length. The distance between pole and focus, called focal length. And also remember this point, the relation between focal length and radius. Focal length is equal 1/2 times r. Let me tell you one point. Focal length, focal point, and radius are real in concave mirror. You see? Curvature, focus, focal length, radius, they are all in front of the mirror. If this quantity be in front of the mirror, we can say that this quantity are real. And focal length, focal point, and radius are virtual in convex mirror. See, center, focus, focal length, radius, they are behind the mirror. and we can say they are virtual. Now I tell you a special rays on spherical mirrors. Light rays incident on a spherical mirror are reflected according to the laws of reflection. We said it before, laws of reflection. The angle of incidence is equal to the angle of reflection. You see this figure in concave mirror? In each point of spherical mirror, we have the laws of reflection, I and R. Also, you see convex mirror, I and R is equal. The following are some principal rays which are used to construct images of objects placed in front of spherical mirrors. Number 1, an incident light ray, an incident light ray parallel to the principal axis. Incident light ray parallel to principal axis is reflected through the focal point. You see incident ray parallel to the principal axis is reflected through the focal point. Okay, what's happened to convex mirrors? An incident light ray parallel to principal axis reflected back so that its extension is called extension, this line, that its extension passes through the focal point. Number 2, a light ray passing through the focal point is reflected. A light ray passing through the focal point is reflected parallel to the principal axis. Let me tell you about convex mirror. A light ray whose extension passing through the focal point is reflected in a direction parallel to the principal axis. Number 3, an incident light ray passing through the center. An incident light ray passing through the center of the mirror is reflected back along the same path. Why? Because the angle of incidence is 90 degrees. Or, sorry, we can say that the incident ray is perpendicular, and the angle of incidence is equal to the angle of reflection. That is why the incident light ray passing through the center of the mirror is reflected back along the same path. Now, convex mirror, an incident ray whose extension passed through the center is reflected back along the same path. Number 4, a light ray incident at the center of the mirror surface is reflected in a direction which makes the same angle with the principal axis as the incident ray. The laws of reflection. The angle of incidence is equal to the angle of reflection. 4. Convex mirror. A light ray incident at the center of the mirror surface is reflected in a direction which makes the same angle with the principal axis as the incident ray. The angle of incidence is equal to the angle of reflection. In this video, I told you about spherical mirror, kinds of spherical mirror, and special rays on spherical mirrors. My students, if you have any question about a spherical mirror, try to comment below, and do not forget follow our YouTube channel. Catch you later. See you next time.